Here we have the Inno3d RTX 3090X3 video card that came in for repair, and the card looks something like this. Customer mailed over the motherboard only and not the whole video card, and he wrote that the card does not work. So without wasting any time, the first thing I like to do is measure the 12-volt line. We have one here and we have one here. We connect an 8-pin cable here and an 8-pin cable here, and that's how we supply 12 volts and 12 volts. So before we do anything else on the board, we measure if we have a short circuit on the 12-volt line, because I would say 50% of video cards that we get in, they have a short circuit on the 12-volt line. If we do not have 12 volts, we're not going to have 5 volts, we're not going to have 1.8 volts, we're not going to have V-core, we're not going to have VMEM, we're not going to have fax, nothing. So 12 volts is important, and that's the first thing that we measure for. So we're going to start with the first connector, and we measure 12 volts at the coil. 0.462 voltage drop. That's good. That's very good. 0.462. And the second one, and look at that. We have a short. We have a short circuit on this power connector here, on the 12-volt line. I mean, I do see corrosion on the board on a lot of areas. Look at this. I see corrosion here on this, what looks like a 0 ohm resistor. Corrosion here, corrosion here. The vias, more corrosion. Let's just do a quick visual inspection on the board. Right now we know that we have a short and a short circuit on the 12-volt line. What is this? Is that board broken, or is it supposed to be like that? That may be a problem. If that board is broken, it may be a problem, because important traces can or may pass through the board. You see how we have a line going through like this? Let me turn the ring light on. We can see more details that way. So now I have the anti-glare light and the ring light. Ring light is very important because sometimes you can see more details with the ring light compared to the anti-glare light, like now. That's the anti-glare. With the ring light on and the anti-glare on, now we're able to see those traces. And this trace is going that way. Hopefully no important lines are running through this broken area of the PCB. Because on Gigabyte video cards, for example, I did a video where Gigabyte refused warranty because of a tiny crack on the bottom here on the PCIe slot. The crack was barely visible, but there are important lines that pass through that crack, which deems the card a no fix. But I do not know if we should worry about this or not. And what's this? Was there a component here? No component here. And maybe we have a crack right here also. I mean, having a 12-volt short is one thing, and having corrosion and a cracked PCB board is another. I do not want to go into a rabbit hole where we spend a lot of time working on this card and we do not see light at the end of the tunnel. Right now, too many things to think about. And honestly, I do not know if we should continue with this card or not, or if I should upload this video or not. We already started. Maybe let's continue. We'll give it a shot. If it works, great. If not, then we'll deem it a no fix. And if somebody else wants to spend more time on this, by all means, you can spend as much time as you want. But we are practical here. I know when to stop, and I know when to continue. Let's go back to the anti-glare light only. The first time I worked on a video card and I saw this where caps were crooked. I thought that somebody worked on the board and they did not know how to solder the caps, even though they are connecting to the same pad. But I did not think that crooked caps, they come like this by default from the factory. All right, and the back looks clean to me. I do not see anything wrong on back of the board. And right now what we're gonna do is inject voltage at the shorted coil, and we're gonna see what gets hot on the board. We wanna track down what's causing the short. Okay, the board is drawing around 5 amps at 2 volts. I did notice what got hot on the board. The thermal camera battery just died, but I did see what got hot on the board. You can rewind that part to see for yourself, but I'll tell you exactly where the heat spot came from. So the heat spot was coming from right over this area here. This controls VMAM, as far as I can tell, but I may be wrong. And to remove this MOSFET, if in fact this MOSFET is bad, then we're gonna have to remove this connector also, because this one is plastic and it's gonna take a lot of heat, a lot of hot air to remove this. If we kept this connector, then we're gonna burn it. It's gonna liquefy like solder. Maybe we do not have to use solder anymore. We can use plastic to solder that chip. So I think the first thing we need to do is desolder and remove this connector. Turn on the ring light. We do not need anti-glare right now. And yeah, I mean, look at this area. This area is corroded. We do not even know if the chip itself is what's bad or if there's anything nearby that may be causing the short, like this cap right here, or this cap right here, or this cap right here. And I do not even know if that's a cap or not. Let me turn the ring light. It looks like a 0 ohm resistor. 0, 0, 0. That's what I think. Let's grab our brush, our fine steel brush, and maybe we can brush off some of that corrosion. Yeah, 0, 0, 0. Go back to anti-glare. I mean, right now we have a lot of tall objects, so anti-glare comes in at an angle, 30-degree or 45-degree light. And the tall objects on the sides are blocking the light, and that's why I have to use the ring light, a combination of both. Now we have a very crisp image, and that's why I said in the anti-glare video, that's how you make use of both the ring light and the anti-glare light to get the best possible image depending on the scenario, on what you are working on. We're gonna do our best, but keeping in mind that if replacing that component does not fix the problem, we're gonna stop. We're not gonna go any further. Let's desolder that connector. And we're gonna desolder it using low melt solder. A few days ago, when I did the video on the Whirlpool dryer, I used the solder sucker, and a few viewers on the channel, they said that the solder sucker should be used vertically and not at an angle. It really does not work for me in any way, shape, or form. Just look at the size of the solder sucker compared to the microscope. It cannot fit under. Just imagine I want to heat up the joint, quickly remove this and position this vertically and not being able to see where the tip is going, over what. But like they say, if there's a will, there's a way. People who have no other option will make use of this. Will probably use this and make it work because they have no other option. But for me, I do have an option. I have an option of low melt solder and a wick, and that works like magic. There's also 101 ways to skin a cat. And don't worry, I'm not gonna skin any cats. It's a saying. It's a saying here in the US. Go blame it on the person who made it and people who made it popular. But there is 101 ways to skin a cat. You can do it in a lot of ways. I can use low melt solder. I can probably use leaded solder. I can use a wig. You can use the solder sucker if it works for you. UPS just came in to pick up the packages. He's gone now. We do not have a short. And we do not have a short. And this one, I do not know if it's normal for that one to read a short. But either way, we're gonna go for the DR MOS. I'm not worried about the small caps. So this one here is reading a short, but that may be normal. I have a donor video card right next to me, which looks somewhat similar. Is it similar? Somewhat similar. And if we measure the cap right here, we also got a short. So we're gonna assume that's not a short. It could be low resistance. We can measure the resistance anyway. If we measure in ohms mode, one probe on ground and one here, we have a high value. We have 200 and something ohms. Yeah, we're gonna assume this cap is good. We have an aluminum cap right here, but we're not gonna desolder it. We're just gonna be careful and we're gonna point heat on this area only. What we can do is I can cover the caps. Done. I mean, just imagine we did not remove that plastic connector. Look at this. It would have been liquid by now. Okay, out. Now we need to measure for a short. Do we still have a short? That's the question. We're gonna measure at the same coil right here and meter in diode mode. This short is gone. I'm reading 0.41 voltage drop. Amazing. Amazing. We pinpointed the culprit, the bad guy, and we got rid of him. Finish him. Fatality. Got it. All we have to do is replace that component and hopefully we can have a working video card. How awesome is that? To save that video card from the landfill. Get rid of the glare using the anti-glare light. And of course we need a lot of flux in this area if we want to do a good job. Because that board absorbs heat like no other board. And we're gonna grab that MOSFET from this donor board that we have here. Very nice. Now all we have to do is press down on the chip and we're gonna apply more heat. And just like that, done. Wait for solder to harden. And we're good. What about that ball here that escaped and ended up here? It's all right. We can keep it on the board as a decoration. But we have one other tiny solder ball that we need to remove. This one right here. And in the meantime, why not do both? Just to save the world from complaints. This one. Right, that's enough. And perfect. Look at every pin. If we turn the ring light on, we can see that every pin is nice. Awesome. All right, so we have both 8-pin cables connected, 12 volts and 12 volts. And now all we have to do is turn the power supply on. But let me put my goggles on in case something happened. That's a very powerful cord. And 1, 2. Actually, let me plug in the HDMI cable also, since I'm very optimistic. HDMI cable plugged in. And let's see, are we going to get 6 beeps? Or are we going to see something on the screen? If we did see something on the screen, the job is done. 1, 2, and 3. Yes, no. I did not hear 6 beeps, but I did now. The card is deemed a no fix. I told you from the very beginning, if we replace that chip and it does not solve the problem, we're going to deem it a no fix. This, as far as I can tell, is the VMAM circuit. And anytime you have a short on the VMAM circuit, it's very likely that you have a dead GPU, based on my experience working on video cards. In addition, I did mention the broken area of the PCB. Let's take a look at it one more time. We do not know if there are any important lines that pass through. I do not know what this is, if that's a crack or maybe a stress mark. We do not know. Like, we see a line here, and that line passes. We do not know what layer of the board that line passes through. Or it may be nothing. The break in here may not affect the video card in any way, shape, or form, but the fact that we got rid of the short by replacing that component and the card is still not powering on, it's very likely that our GPU is cooked, is gone. Probably received more voltage than what it can handle. So we're gonna call it off for this video card. I hope you enjoyed the video. Don't forget to like and subscribe, leave a comment if you have any questions, and we'll do something else in the next video.